Hi, everyone. I'm Ivy Lu from Capital One. I'm a data scientist. So today I will talk about our real-time pipeline for second look use case using Spark and Kafka. Behind our second look product, we are a cross-functional team with data engineers, data scientists, a product manager, business analysts, and many other roles. So I feel very honored to come to Spark Summit to present our use case on behalf of my team. I will give some introduction and background knowledge about our use case, and then I will describe our real-time pipeline in detail and provide some technical lesson learned. And finally, I will share our customer feedback. So before I jump into the talk, let's do a quick show of hands. So how many of you have a Capital One credit card? How many of you have received second look alert? Cool, great. So another question is, raise your hand if you look at your credit card statements on a monthly basis. Basically, you look through your statement line by line, go through each of the transactions, and make sure it's correct. That's pretty decent amount, so you are always stay on top of your spending. That's great. However, like somebody like me, I didn't do that like very carefully. So when it's time to pay my credit card, I always just look at the amount. If it's about the right amount, it's about the number, I'll just pay it. If the number is kind of a surprise, I'll go through the statements line by line and see if there are any surprise. So for our second look use case, it begins with the same question: how closely do you look at your credit card statements? If your answer is not closely enough, you are probably not alone, because the recent research from Capital One reveals some of the real unexpected charges. For example, you may be surprised that 2/3 of the people will overlook potential duplicated charges. And when our customer find such charges, they may become nervous and they may constantly checking their transaction activity. We are here, we want to help with our customer so that they can sit back and relax, and they can always stay on top of their spendings. So when talking about unexpected charges, people may always thinking about fraud. Last year at the Spark Summit, our VP of Technology, Chris D'Agostino, gave a talk about some fraud use case in Capital One. However, there could always be some transaction that's not a fraud, which are some transaction you authorize yourself. Either you were there in the merchant in person, or you authorize it online. But in the end, you still find that you were incorrectly charged. Some of the unexpected charges could be duplicated charges. So the merchant may accidentally double swipe your card, which will result into a duplicated charge. Or, for example, generous tip. Say if you're having lunch at a restaurant, you leave a tip, and the waiter or waitress may fat-fingered with your numbers. Or if you go out for dinner with a bunch of friends, and the tip is already added to the bill, but you didn't notice, you leave an extra tip which you didn't mean to. Or there could be some other situation. Another type could be a spike in your recurring bill. This could happen for some merchants. They raise price, but you are not noticed that before. Or, for example, your cable or your internet provider, they may provide you some discount amount for several months, but then they raise your price and you may not notice that. So overall, our research finds that customers are on average incorrectly charged around $150 per year. So we want to help customers to save those money. So second look is a feature created by Capital One to detect and notify cardholder of those unexpected or potentially wrong charges. Here is an example of our second look as a feature and benefit for all of our credit cards on our homepage. So we bring the attention to the customer automatically through emails and push notification in our mobile app so that the customer can take timely action. So the situation can be resolved through a conversation with the merchant or through a dispute directly with Capital One. We help guide the user through the whole process to guarantee a best user experience. Here is an example of the second look alert you may receive from Capital One. It says on the left, we notice you give a generous tip on what day at which restaurant. So we provide a summary of your transaction. In this case, it's base bill, tip amount, and total amount. Hopefully, this can refresh your memory and to recall whether this tip is authorized or not. You may or may not have done this on purpose, but we find that customers still find it very useful to be notified of the transaction that fall out of their normal behavior. So on the right-hand side, that's a second look alert in our mobile app. So it also provides a lot of detail, like on which day, which card you are using, what's the merchant, what is the transaction amount. And in this mobile app, we also provide channels so that customer can send feedback to us. Here in the bottom, it says this charge is correct. So it could happen you just happen to buy two things at the same price at the same merchant in a short period of time. For example, 2 cups of coffee, you just buy it twice. So if that's the case, you will click yes, this is correct, and then you are all set. However, if it's truly duplicated charges, you can click no, help me to fix this, and then we will get you through the dispute process. It's very straightforward. So second look program, in the initial phase, we launched on August of 2015 for our email alerts, and for the push notification, we launched in January 2016. We use Hadoop MapReduce for our data pipeline. It's coded in Python. We use MongoDB as a NoSQL database to store all of alerts. And we use Luigi by Spotify as a job scheduler. We have a pretty good coverage. It's auto-enrolled for all of our credit card customers. We have tens of thousands of alerts sent per day. We have tens of thousands of customers that's reached by these alerts. And we covered several different types of alerts. After we launched the program, we find that we try to keep improving our product. We find that there is a huge gap between when people transact at the merchant and when they receive the alert. This could be due to like data movement between the system, data delayed from the data source, or the data pipeline runtime. We try to close this gap, and eventually we want to send the alert in real time. So imagine like if you receive alert that several days later after you transact, even you gather some detail of the transaction, you may still feel very confused, like, am I making this transaction or not? So if we can send the alert in real time before the customer taking their card back to their wallet, they will get the alert and they can solve with the merchant's insight. So that's why we built this real-time pipeline. This is our current phase. This is probably simplified architecture of our real-time pipeline. So everything begins from the customer. So customers shop at the merchant, and then the transaction will go to a system called TSYS, which is total system. That's the transaction hub for almost a majority of the credit card transactions. And TSYS, as a third-party vendor, will send us our transaction back into our system. And they are sending authorizations and posted transactions. The authorization is coming in real time, and posted transaction is coming in a batch load. So the difference between authorization and posted transaction is the authorization is it will show up on your card as pending transaction. It's not settled yet. So if you, for example, if you check in at your hotel or you open a tab at the bar, it will authorize you amount, but that's not the amount you will pay eventually. Whereas the posted transaction is the settled one that will show up in your statement and contributing to your balance. So the real-time one is the one we are focusing, and it will come into a Kafka connecting to a lot of detectors. So for each of the detector, we have separate Kafka topic that will send the relevant transaction into the relevant detector. And for a lot of the detector, it will also connecting to a database to query and to perform the logic and to generate the alert. Once the alert is generated, it will connecting to another Kafka, which is sending the alert to our messaging system. And right before the messaging system sending the alert, it will push the alert back as a backup to our database again. And the alert will eventually receive by the customer. So we use Spark for majority of the logic, like for all the detector logic, and we use Kafka to connecting different components. We use Postgres and Cassandra as our database, and everything is on AWS. So the first feature of our pipeline is microservice based. So every component is a distributed, decoupled job. So this enables us to update every single component without dependency for others, and also make our pipeline language independent. So for example, some of our detectors is written in Scala, others are written in Python. Another feature of our pipeline is it can handle both real-time and batch load. So for our posted transaction, it's come to with a large batch load. It's a high volume. We will process it relatively slow. But for the real-time data, the authorizations is medium to low volume, and we can process it pretty fast. We have separated Kafka topic for batch versus real-time, and we set a threshold window for how many records we are sending downstream. This is also constrained by our downstream messaging system. We don't want to overwhelm the system if we are processing a batch load. Another thing we find is duplication. So we find there's a lot of duplicated record in our system. This could due to several reasons. So first, at the data source in TSYS, they only guarantee at least once. So from data source, it already produced some of duplicated records. And also the Spark and Kafka job, when it runs, they all produce some kind of duplication. We tried a lot of to do some research on where is the best place to perform deduplication, and eventually we find it works best to dedupe at where it matters most. In our case, it's the database. We definitely want to make the transaction in the database unique, and we want to make the alert that we send out to the customer unique. We don't want to send duplicated message to the customer. So we dedupe dedupe at the database by make the REST API idempotent. And another thing I want to talk about is checkpointing. In our application, our goal is to achieving zero data loss. We want to process the data at least once because we already have a good solution for deduplication. So it's okay to produce some duplications throughout the system, but we don't want to any data loss. In this case, we can use either Spark checkpoint or Kafka offset. Spark checkpoint works very well for disaster recovery. However, it requires a serialization of your process. So if you keep updating your database or your code base, and reuse the old Spark checkpoint, you will result in, like once your job start again, you will result in that using the old code base because it will automatically use the serialized version without not using the newer version. So in our case, we need to update our code base pretty frequently. So it makes sense to use the Kafka offset. And another thing we find that's interesting is where to save the offset. For our system, there is a large latency. If we try to save the offset to HDFS or to S3, it could be several seconds, and that's too large latency for our system. So we find it works best to save the offset to Zookeeper because our offset file is also very small. So after we launched I should mention, Alex our team member has a very nice blog post about this topic. So feel free to check the link and read his blog. Since we launched the program, we received tremendous user feedback through social media. So here are some of the social media feedback from Twitter. So the first one reads, thank you, Capital One, for taking a second look email. You saved the money. And another was talking about a restaurant add a tip without my permission, and you caught it. And this two was talking about there are some high charges than normal, or there's an overcharge I otherwise may not have noticed. We are very excited that our customer love the product. We find that sometimes even the alert, the transaction that mentioned in the alert is legit, there's nothing wrong. The customers still feel glad because they got notified for suspicious or potentially wrong charges. And we also set up an email box to receive feedback from customer. This is a word cloud I made from the emails that we received. And you can see some top words used here. For example, tip, charge, amount, alert. And a lot of people just writing the email saying thank you. So they definitely love this feature, and we are so glad. For our future plan, we would like to leveraging more power of machine learning and data science so that our alert will be more accurate, personalized, and relevant. That's all my talk. And feel free to let me know if you have any question. Thank you. Go ahead. Wow. We are a lot of persons. We have a lot of people. Probably 20. Yeah, around 20. Yeah, we definitely need that. I feel like that's a question for our engineers. We have a lot of engineers sitting at the audience. So yeah, maybe you can chat with our engineers afterwards. Thank you. Go ahead.
What's the biggest lesson you learned in basically putting Spark and Kafka together to work against multiple transactions, since that's going to have its own latencies?
big is a lesson learned for specifically for transaction or for Spark and Kafka?
Implementing Spark and Kafka in a more real-time architecture, dealing with the latency of the transaction system. What did you learn? There are any sort of like gosh darn lessons that you learned from putting the two together?
Yeah. Yeah, thank you, Alexis. Any question?
Wondering if you could say anything about your features and maybe some things about like qualifiers and false payments. I imagine you might have a fair amount of like
Yeah.
things that look like repeating charges but aren't bad, or like bad restaurants, things like that.
Yeah, that's a good point. So we do like comparing with accuracy and coverage. We care more about accuracy, so we can sacrifice some coverage because we don't want to send wrong alerts. So this may cause more confusion in the customer experience. So we do have some like whitelist and try to make sure everything works. We did a lot of testing to make sure that whitelist actually works.
Is that part of the model, or is that just something you apply separately?
Yeah, we apply it separately, and for the model itself, we also consider some kind of a feature for whitelist.
In your diagram, you had all the detectors in the middle. How many detectors are you running?
I would say that's a little bit secret sauce because our competitor is also trying to build probably same feature. So I would say we have a lot of different type of alerts has been implemented. So that's more than what I listed here. Go ahead.
So this sort of fraud detection is detecting an anomaly in some behavior, right? So do you also send alert if I tip too less compared to how much I usually tip?
No, we don't charge our customer. And also this is not about an anomaly. It's about like potential wrong charge. So it could happen like if you are overcharged.
Maybe a shift in behavioral patterns, so to say, that we are trying to detect.
We haven't done much on like user behavior specific research, but this could be like our next step for our personalization. Go ahead.
How much of this is like machine learned versus rules? Like, for example, the double charging could be two charges that are same in any given one day is a rule. Versus you have features about how many double charges, history of the user behavior.
Yeah. So for some of the alerts, we definitely have a model behind that. For other alerts, if it's very straightforward, we just use rule-based. Yeah, so in the future, we try to leveraging more data science into the system. The gentleman in the back.
How do you come up with your topics?
How,
Yeah, like your Kafka topics?
how do I come up with the Kafka topics?
Yeah, how do you define topics for yours? Is that sort of like start off with a small sample and then try to expand it?
Yeah, as I explained, our Kafka topics is corresponding to the detector or the type of alerts. Yeah. Go ahead.
Do you have any mechanism to feed user response or feedback to your system?
Yeah, that's also in our next step. So we do have some, like I showed the user UI before, we do have a channel so that user can tell us whether it's correct or not. So in this case, we are not only show the problem, we also provide a solution. But this feature is more for the dispute process. So we want to make the dispute user experience pretty smoothly. And in the future, we try to collaborate more of the user feedback data, maybe to like as a feature to train our model, so that it's more relevant to the user. Go ahead.
You mentioned that the first approach was very slow getting users back. Can you comment on the new approach, how fast you're working on that?
Oh yeah, sure. So the first We were using Hadoop MapReduce and everything in Python. And also we are using like the posted transaction, which are come as a batch log for the first phase. So it could be some delay between when people receive the alerts. Whereas in the real-time pipeline, as I mentioned before, the latency would be like before you even put your credit card back in your wallet, you will receive the alerts. That's how fast it could be. Go ahead. How is the data ingested? Yeah, it's the total system, like TSYS come inject the data into our world. Yeah. Go ahead.
Did you have any challenges with PCI compliance?
Yeah, so in our at like before, probably 1 year or 2 years ago, before Capital One fully go on for Amazon, we were having some concerns about Amazon, like for the PCI or MPI data, but then we set up a specific rules and encryption and all the protection to make sure that there will be no leakage for our data. Okay, cool. Thank you.
All right, thank you. I think I will stick around for a few minutes for additional questions. So next talk is in 10 minutes.